Today we're going to be starting our integers unit, and we're going to be starting our integers by talking about real number system. This is a system that we use to organize different types of numbers, and integers are part of that set of numbers. So we're going to talk about where integers fits and how integers is different than all of the other numbers. Let's start with some key ideas. So starting off, when we're talking about real numbers are all the values on the number line. Real numbers can be classified using characteristics, that's things about different numbers, and then we break them into subsets, and subsets are categories of numbers with similar characteristics. Let's take a look at a real-life example of this. So here's a real-life example of something that looks like the real number system. And our real-life example for you guys is going to be Robinson. So at Robinson, there's you. By yourself, you're just you, nobody else is you. When you net every single person at Robinson, the only person that's you is you. However, you're not just by yourself inside Robinson. There are other subsets that you belong to. So for example, you're on a team. Either on the Champions or the Eagles or the Stars or the Comets, you're on a team. You're not on all the other teams, but you are on one team. So you're you, yourself, and you're also the member of a team. Now, all of these teams are in the 7th grade. Are there teams that are not in the 7th grade? Yeah, they're the 8th grade teams. But these teams are in the 7th grade. So you're on a team, you're in the 7th grade, and you are you. And you are at Robinson. So you're all these things at the same time. Now, the 7th grade is inside the middle school. Are there things that are in the middle school but aren't in the 7th grade? Yeah, that's the 8th grade. So you are on a team, you're a 7th grader, and you're in the middle school at Robinson. You're all those things at one time. But certain people are only on your team, certain people are only in the 7th grade, and certain people are only in the middle school. So completely separated from the middle school, but still inside Robinson, is the high school. And you are not a high schooler. Not yet, anyway. So you don't fall inside the box that's in the high school. The high school is completely separated from the middle school, separated from the 7th grade, separated from the team that you're on, separated from you, but still inside Robinson. So that's a real-life example of the real number system. It's subgroups that all work together within each other, but some things are separated, some things are some things, and they're not other things. That may be confusing, but you just have to remember, while you're you, there are things about you that are characteristics, like being on a team, being a 7th grader, being in the middle school, and being at Robinson. Let's take a look at how this applies to the real number system. So here we are at the subsets of the real number system. And again, it kind of looks like our Robinson picture, but instead of filling in things like you and team and the 7th grade, we're going to fill in things that have to deal with real numbers. So the smallest set of numbers is numbers that we call natural numbers. Now, natural numbers are also whole numbers, and whole numbers are also integer numbers, and integers are also rational. Now, there are a whole set of numbers that are separated from the rational numbers, just like the high school, and those are the irrational numbers. So you have numbers that are either rational or they are irrational. They can't be both. Now, we could go in depth on each one of these subsets of the real number system, but we are only going to focus on integers in the 7th grade. You will learn about all these different sets of the real number system, but for today, and in 7th grade only, we're going to focus on just integers. So let's talk about integers now. So integers are whole numbers and their opposites. So a whole number is a number without a decimal or a fraction. So for example, 6, and an opposite of 6 would be -6. Integers can be positive or negative, like in our example of 6 and -6. Integers cannot have fractions or decimals. That's very important. If you see a number that is a fraction or is a decimal, once you've reduced the fraction, if it is still not a whole number, it is not an integer. And they can also not have any decimals. We write the set of integers with this little set notation sign, then ... showing that it goes on forever and ever in one direction, -3, -2, -1, 0, +1, +2, +3, and then again, ... stating it goes on forever in the other direction, because this again is an integer set that could go on forever and ever, and then we use our set notation. So remember, integers don't have fractions and decimals. That's very important, and they can be both positive and negative. Let's try some practice on our own. So here at practice number 1, we've got 6 numbers, and we're going to determine whether those numbers are integers or not integers. Now, I want you to try this on your own first before we look at the answers. Remember, if you've got a fraction, make sure you reduce it all the way before determining whether it's an integer or not an integer. You're going to write the integers in the integer box and the not integers in the not integer box. Go ahead and pause the video now and then press play again to see if you are right. How did you do? Were you able to identify the things that are not integers versus the things that are integers? Let's take look at the side that says integers first. So -8 divided by 2, if I work out that math, I get -4. -4 doesn't have a fraction, it doesn't have a decimal, it is a negative or a positive, so it is an integer. 0 doesn't have any decimals, doesn't have any fractions, so it is an integer. Now looking at our not integers, 3/4, if I were to reduce that down, it's the smallest fraction it can be right now, as a decimal would be 0.75, and since I know I can't have fractions or decimals, it is not an integer. Pi is a number that goes on forever and ever and never stops as a decimal, so that is not an integer. 1.2, oh, I immediately see a decimal, so since I see a decimal, I know it cannot be an integer. Same thing with 0.3 repeating. It is a decimal, and I can't have decimals in my integers, so it is not an integer. This brings us to the end of this video. If you like this video, go ahead and throw us a thumbs up. If you love this video, go ahead and throw us a sub, and we will see you in the next one.